फाइव वन टू थ्री फोर जब हाँ स्टार्ट कर सकते हो
अनिमेश स्टार्ट करें क्या?
हाँ हाँ करते हैं ना
ओके ठीक है, रुको स्क्रीन शेयर करने दो मुझे। Hello everyone, I hope my screen is visible right now.
हाँ दिख रहा है अभी
Okay, good enough. So I hope you remember what we covered in last session. In last session, we talked about file cloaking. We talked about how to load binaries from RAM without touching the file system. So this session is basically going to be extension of previous session, and what we have done that we have combined everything together and added bunch of more things in this session. So before we start, we will start from something very basic, and that is dynamic loading of libraries and how to resolve symbols. So what we are basically going to do that so far what we are doing that we were writing basically monolithic malware, which means that whole code is sitting in one fat binary. And obviously this is easy to do because we write whole code at once and we compile it in one binary, but then there are certain problems with this approach. So the first very obvious problem is that a malware analyst can analyze whole code because everything is already there in binary. That is one. Second thing is that if we want to enhance the payload, we have to compile whole thing again. And the third one is that for any new feature, it needs to be developed within trees. That means that if I write the basic version of malware and tomorrow you want to extend that, you will need the entire source code from me because there is no other way to extend that. So here what we are going to do that we are going to sort of deal with these problems, and what we are going to do that we will write rather modular code, which means that there will be multiple parts. First one will be stager, which will load and unload remaining part of code as per need, and then there will be other codes as independently loadable modules. These may be shared objects, these may not be shared objects. There is no restriction that we have to keep our all the code as shared object. We can keep part of code as something like position independent shell codes, or somewhere in between shell code and shared object, or some sort of combination of these two. There is no limitation that we have to settle it one at and only one thing. The only thing is that if we settle with some particular approach, we have to ensure that our stager can load and unload every approach that we are going to use. For example, if I am going to use shared object only, that means that my stager must know how to load and unload shared object and how to call specific functions from it. Similarly, if I want to only deal with position independent shellcode sort of things, so my stager needs to have only the code for that part. But if I want to deal with both of these, then I have to figure out a way to deal with both in the code, and that code must be present in stager. Second thing that we are going to do that all parts will not be in same place, which means that stager can be at victim machine and modules can be fetched from remote servers. Now here there is another plus point for us with that is that I suppose I want to update some particular module, then I do not have to deal with, then I do not have to update the stager. I just have to put the updated copy of module on command and control server, and my stager will pull it happily. So this is another advantage. Upgrades are very easy, and of course, since my modules are at command and control server, the malware analyst won't be able to grab all of them. Hopefully, all he will get the stager and possibly couple of modules that were already deployed there, not whole thing. Next thing is that we can do that we can keep modules encrypted with different keys and then decrypt only the modules that are needed right now. Now suppose I want to scan certain files on victim machine and I want them to be uploaded on my server. So I will only decrypt the related module, run it, and once it is done, I will simply remove that module from memory. So that way, if someone is going to dump the whole process, they will not be able to get every single code decrypted in the memory. And if we want to harden it further, what we can do that we can re-encrypt unloaded modules with different key. So every time the module is loaded and unloaded, it gets encrypted with different keys. So if you take a dump of memory at different times, you will get completely different data. That is yet another nice point. Here, because of modules, we already have mitigated the second limitation, and third one is also mitigated because stager can be deployed while we are writing more and more modules to be loaded. How exactly we can pull this off is something we will be covering very soon, starting from very basic code, and the code is here. Here my shared object has only one function, that is hello, and if you remember from previous code, session 5 load from rank and share.c. In previous session, we were putting this attribute, this constructor one, which was basically calling our function as soon as our shared object was loaded. Here we are not doing anything like that, which means that once my shared object is loaded, this will not be run automatically. So here what we are doing that Probably you are already familiar with this code. We already covered this in previous session. Just like previous session, we are opening a handle to our file using dl open. Then bunch of string is there, and here what we want to do that once we have a valid handle here, what we want to do that we want to find address of this particular function in our shared library, and once we have the address, we will simply call it using that address. So here what we are doing that here we have declared a function pointer, and this function pointer will point to any function which takes exactly 0 parameters and returns absolutely nothing, which is the case here. So we have function pointer here, and then using dlsim we resolve this particular function, and then we typecast the pointer to this function pointer, and then we simply call it using the function pointer. And once we are done, we are going to close the handle, and at this point this binary will be unloaded. Now here if we run this, opening, loading, calling, hello, here we are seeing this thing is getting printed on console. That means we were successful in resolving this particular function in the shared library and calling it. Okay, so any questions so far? This is the very basic code that we will be using again and again and again. Any questions? Okay, if there are no questions, we will move to our second example. It is again similar to previous one. And here what we are doing that instead of resolving only one function, here what we are doing that we are resolving two functions. Just like previous one, we just need to have suitable function pointer that we want to uh, uh, load and call, and once we have that, we can use this particular function dlsim for as many functions as we want. And once we are done, again we can simply uh, DA close after destroying every resource that we have allocated. So these are two very basic examples that we will be using again and again. And here if you see that we have used something called external. This is because we do not want our function names to be mangled. So for that we have to specify this. So these functions will be linked using C linkage without altering the function names, so that we will be able to resolve them using DLSIM and passing this. If these functions are mangled, we have to pass mangled name here. Any questions so far? Am I audible to everyone? Hello. Okay. Does anyone have any questions? Yes, Tej. You got any questions? Okay, fine. So we will move to our next example, and that is plugin engine and how to write plugins. And for plugins, what we have done here that we have converted our keylogger X11 keylogger and X11 mouse logger that we covered in our second session. We have converted those two shared objects How exactly that is done, I will cover soon. And before I do that, I have to explain how to write a plugin engine, as in how to properly deal with this stager part. Now here I want to suppose deal with dynamic loading of modules, and here what we want to do that we want to load multiple modules at once, and we want to keep track of all the loaded modules, and we want some way to distinguish every module, and then module specific initialization and tear down, and finally unloading of all the modules. So here what we will do that since we want to keep a track of all our modules and which part is defined where, we need to keep some data with us. So what we will do that of course we are using dl open and dl close. And now if we are going to use dl open, we also have to keep a copy of all the handles to call dl close, otherwise we won't be able to clean up the stuff properly. So what we have to do that we have to keep all handles, and s- this is the basic part, and then we will keep loaded module IDs that we have loaded here, so we can find out at runtime which module to call for which thing. So here what we will do that for this we will use std vector, that is sort of dynamic array that we can expand and shrink at runtime as we see fit. This too we will store in std vector, because we do not want to resize the memory manually again and again and again. That is too much headache. We want to be lazy. Once we have this data, then what we want to do that we want to define common interface for all modules. Why it is important? Because if I am going to use dl open and then I am going to use dl sim to resolve some function, for that I need to know which function to resolve. And if I do not know which function name to resolve, I won't be able to run the particular module. So we have to ensure that all our modules are using same function name for same task, so that way we will be able to run any module. So what we will do that we will do bunch of things. We will have a module init that will deal with module specific resource allocation setup etc. And then similarly we will have something like module exit that will deal with module specific cleanup. For example, certain module wants to allocate RAM or keep a handle to certain device at startup, so those will be created in module init, and those will be destroyed in module exit. So here we have dealt with setup and cleanup part of modules, and then we will have something like run or start or whatever we want to name our function, that will basically run core functionality of our module. Now here we can be way more complex. For example, we can figure out certain way using which every module can somehow uh, disclose its feature set or whatever functions it supports to stager, and then stager can deal with those dynamically, but that will be too complicated right now. We will do that at later stage, but right now we are trying to keep our things very minimalistic here. And once we are done with this, yes, we also need somewhere to for example, we can keep some sort of function name called id or name that will module specific name or identifier that we will use to track the modules. So once we are done, so here what we can do that once we are done with this part, we can basically load any module we want as long as the module is following the same interface, basically using these bunch of functions. Using that, we can call any module we want. So this is how our basic plugin engine is written. So this is the time to show some code and make clean. So main.cpp. Wait. Plugin loader. Is okay. Now, before we start writing our plugin loader, we have to specify our common interface here, and for that we have created a base abstract class that is here. As long as this particular thing is implemented by every module, we will deal with it here. This is the function that we will call once we want to run the module. We are passing it a string parameter using which we will be passing module specific parameters to module, and similarly, the output will be captured as a string if there is one. For identification, we are using a name function. This is load and unload for module specific resources. So this is the basic interface that we are going to follow. And once we are done with this, our plugin loader is very simple actually. This is how we are going to use it. We specify a base path from where we want to load, and then we want to simply load all the shared objects from there. And once we are done, we will simply print which modules are loaded or not loaded. So the loading part is actually very simple. We start with module root path that is supplied here, which is basically some path at local file system. And here we are going to iterate over every file located at this particular file. Here again I am using C++17, and first we are checking if the extension is .so, that means it is shared object. If the extension is .so, we are simply loading it using dlopen, just like our previous code. Then there is certain error checking to ensure that we were able to load it properly. Once we have a handle, we specify, we find out this module init. Then if we are able to resolve this, we simply call it, and then once we call this function, it gives us pointer to object of certain class that is derived by this. That is the class that is implementing the most of the module. So once we have this part here plugin, we simply keep it in our local data store that is uh, defined here. Here we have two lists: loaded modules and the modules which did not load correctly. And then here we have a vector of handles and vector of plugins. Here we want this to load the modules, to unload the modules and call them at runtime. Here we have to keep this to close all the handles at exit, and these are for our own bookkeeping. This is what we are going to show to user, that this many modules are loaded, select which one you want to run, and so on. So here, once the load part is successful, we figure out its name by calling the name function that was defined here in its base abstract class. Then we simply push back that plugin name in loaded module list. We keep a copy of handle and we keep a copy of plugin. If this part fails, we unload the plugin and close the handle and push the path in failed module list. This is the very simple way of loading arbitrary number of modules. Unload part is very simple. Again, we are iterating over handles, and simply we are finding a reference to module exit. We are calling that. Then we are unloading the plugin and closing all the handles. Then we clear all the vectors, remove every data, and then we simply exit. Here we want to run module. We pass certain parameter here, and then it figures out which module is this from uh, this vector, and then it simply runs it by calling the run, that is again uh, defined here, and we are passing certain parameter as applicable to this one, and then we are simply returning the result. So this is a very simple way to load and unload modules. Does anyone have any questions so far? Okay, so since no one has any questions, we will move to a quick demo here. We will compile whole thing and we will try to run it. Here we see that our keylogger, mouse logger, and demo plugin has been loaded. Demo plugin is very simple one actually. If we go to this one, and this is the thing that this is basically a very basic template of plugin that can be loaded by our plugin engine. We create a class, derive it from abstract plugin. We define constructor descriptor as needed. Then load and unload. Here I am not doing anything, so I am simply returning 0. That is the basic way to figure out, say that there is no error basically. Then in name we return demo plugin, and in run we simply print a string and we exit. And module init and exit are defined like this. For init, it will just create a new object of demo plugin class and return the pointer to it. And similarly, at exit, it will delete that object from memory. So here, if I suppose if I select 3, it will run that code and exit. And since the module has exited, we are back to our menu. So it basically says the demo plugin has executed. And now if I want to uh, run my keylogger, so I select 1, and here if I type who am I, here we are getting the keystrokes just like we were getting in our second session. So let us exit here. Similarly, if I run mouse logger and I move mouse, I get the mouse related events. So this is basically a basic smoke test that my plugin engine is working. And now once we are done with this part, we will move to show how keyboard and mouse logging part is implemented as plugins. So what we have done that keylogger.cpp and mouse.cpp. Here again for mouse, again here if you see that we have defined a class, derived from same abstract class, and we did some basic implementation. And for run, we have basically copy pasted the code from mouse logger, and other remaining functions are kept as it is. For example, if I go back to session 2. Oh shit. Now here, if we go here, this is the main function that I have simply copied here in run, that will be called, and other functions are simply copied and pasted here as it is. So this is all I have done. So again, what happens that these functions are called, and when I want to run, this calls this run function, which is basically just a replica of main function, and my mouse logger works as usual. Exactly same thing I have done in keylogger as well. Same sort of basic implementation. Then a copy of main has been copied in this run part, and module init and exit are implemented as usual for returning a pointer to object and removing that object from memory at time of unload. So this is how I have implemented keylogger and mouse logger as plugins. Similarly, we can write as many plugins as we want, and it will be happily loaded by our plugin engine that we have wrote so far. Okay, is this part clear? This whole thing, the custom module, loading and unloading the module. Does anyone have any questions so far? Any questions? Okay. So once we have done this part, then we will simply extend this to move to this part. Here now in our next part, what we are going to do that instead of, wait, let me go back to plugin engine. Here we were loading it from file system, but right now I do not want to load from file system because I do not want to keep all parts of my code at same place in victim machine. So what I will do that I will only drop the stager, that is uh, a copy of this binary, and I want this to be able to figure out which modules are available on server and uh, load them accordingly. So what we will do that uh, again we will extend the same code, and apart from what we have done so far, we will need some more things. We will here we will need some c2 url and path, and we will need module inventory on server that will be used by our stager to figure out which modules are there with whatever names. And once we have no, we need to know path of, okay, path we have already covered. So once we are done with this, we need some way to perform http or https requests. And once we are done, we can basically implement this. So here what we are going to do that for this we are going to use Python 2, and for this we are going to use curl library because we do not want to implement whole protocol on our own. And once we are done, we also cannot write modules on disk, which means that we will again be using memfd create function to keep modules in RAM and load from there. Of course, this depends upon kernel version. If version is greater than or equal to 3.17, it will work. Otherwise, we have to use shm create function and keep our modules in slash dev slash shm. So once we have all parts figured out, we start modifying our code, and the modification is actually very simple. Before we even start doing anything else, we what we do that we try to wrap our curl implementation in a nice class that we can use, because code written using curl can be really clunky at times like this, which we do not want to repeat again and again. So we abstract it away in a nice class, and here we define certain functions. We need somewhere to dump the response in a string, and we need somewhere to download the content to file by path and by fd both. This path will be needed if we want to download it somewhere on file system, or if we are trying to using slash dev slash shm, in that case this part will be needed. Or if we are using this memfd create, in that case we will be using this. So the actual implementation using libcurl is actually very simple. There is this basic mechanism that we initialize curl. We set certain options. Again, first option is url. Then I have disabled ssl verification, just in case some server is using https and it is using self-signed certificate or something like that. And in that case, this will ignore the sanity check and will proceed with https connection. And then here I have set user agent. You can set it to any browser you want to spoof. And then we finally need data and callback. Here we want the string, the response string, to be saved in another string. So since we want to deal with on our own, we have to supply our callback. So there are two callbacks defined. One is for writing in memory, and one is for writing to file. Signature is pretty much similar. First parameter is pointer to content. Second is size of one unit. Then next is total number of units. That means that if we multiply these two, we will get to know the real size of contents in bytes. And then this is the user supplied data actually that we are supplying here. So here what I have done, that I have created a string variable, and in the write memory callback, what I do that I calculate the real size by multiplying these two. Then I typecast the pointer to a steady string, and then I simply append the contents back to this string. So once this function is done with, I have all the data in this particular string. And just to ensure that we do not leak response from previous calls, here I have set it to blank string before initializing curl. Similarly, if I want to download to certain file descriptor, again here I have used uh, file callback and passed this fd. And here what I have done, this code is very similar. Again, I have calculated the real size in bytes using this, just like this one. Contents is here, and I simply call write function, which is basically a thin wrapper around write syscall on Linux. So this call will simply write this much data from this buffer, this much data in this particular file descriptor, and then it will return the actual number of bytes that have been written. This is required by curl to invoke next call to this callback with remaining data, just to ensure that all the data is written properly, because at times write may return before writing all the data that we have sent it to write. For example, if our process is writing and for some reason operating system decides that it is time for another process to get time slot on CPU, in that case this is call will return prematurely and we will know exactly how much data have been written. Since here there is no such risk, we simply return the actual size that was given to us, but here we are returning the return value of write. So once we are done with this, here we can do this, and then for uh, download to file uh, path, this one here, what we do that we simply reuse this function, and to reuse this we open this path that is supplied here using these many flags. This is basically opening the file for read and write. This flag specifies that file must be created if it is not already existing, and this mode defines that the owner should have read and write permission. So once we are done with this, we can simply use this class to download and run our modules. So for that, what we do that and here we have modified the base class. Actually here we are keeping a copy of all the file descriptors as well, because whatever file descriptor we are creating using memfd create, this needs to be closed, otherwise we will be leaking file descriptor that is sort of limited resource on any system. So for that we need to keep track of file descriptors as well. Rest of the stuff is same, and in plugin loader again the code is very similar. Actually here instead of file system path we are using a certain url, and here what we are using that we are simply trying to access the inventory. Then we get the server response in this, then we try to split it on new line. So basically our inventory is very simple actually. Wait, here our inventory is very simple. It just contains name of shared object file, one file per line. So here we are simply breaking it apart at new line. So this dynamic array will have three contents here. First one will be this, second one will be this, third one will be this, and then we simply iterate over all the modules, and we are creating a hidden file descriptor in memory using memfd create, then downloading file to this particular file descriptor that is entirely in RAM without touching file system. Then we are getting a file path from procfs, and then we are simply using dl open, and remaining part of code is exactly same. The only difference is that we have added one more line to keep a copy of open file descriptors. The rest of the code is uh, same, and the only change that we have done here that we have added another loop to close all the file descriptors, and here we are clearing this file descriptor vector to clear all the contents from memory. Apart from these two three changes, every part of code is exactly as previous one. For example, if I want to check exact changes that were done in this code, so that is actually very simple. If plugin loader.cpp and okay, session 5, okay, yes, plugin engine plugin loader.cpp, and now here we see that okay, this particular function is added because I want to split the string. Then this part is added, this part is added, this part is added, and then these parts are added. These parts are the lines that we have moved. For example, here I have removed this line and added these two lines instead. So this is the only change that we have in the code, and once we clean it up. Okay, so here we have built all the code, and here I am going to start basic HTTP server, and here I am going to run this plugin engine. Again, it has loaded all three modules here, and if you go here, it has got request to inventory. That is the first request. Of course, we want to get a list of all the modules that are available on server. Then all three modules are loaded, and they are downloaded and loaded from here. And if we want to check, we can exactly check in procfs plugin engine. So okay, so s cd proc /2a273/fd, and if we want to see, we see that there are a total 6 file descriptors, and if we want to see where they are loading, now see, here we have loaded three modules, and here for them we are getting the entry like this, and this is deleted, which that means that after loading all this, these file pointers have been deleted from memory. And this part is coming from our code, where we have called memfd create. Wait, here, this is the first parameter. This string is populated here. This is just for debugging purpose. Here we can choose to supply blank string or some other dummy string or same string everywhere, so figuring them out will be more difficult at analysis time. But yeah, this is how it looks. And here again, if I want to run my demo plugin, well, that works. Similarly, if I want to test my keylogger, oh wait, of course my keylogger is working. And if I want to check my mouse logger, well, yes, it also seems to be working. Now here, these modules need not to be in plain state on server. They may be encrypted. So in that case, once we have downloaded it to file, we may try to decrypt them in place, or we may try to download the content in string by calling this function and then decrypting it in RAM, and then we copy it to memfd create file descriptor to load it actually. So that is an obvious enhancement that can be done here if you do not want to keep all the modules in sort of plain state. So yes, this is the basic way that you can do it at your own end. Okay, so any questions so far?
So,
Yes.
in that curl function, you have mentioned about the first parameter for the right function. What about the rest of the parameters? Is it passed internally or
Do you mean these all these functions?
no? For that right memory callback,
This one?
yes. In that there are four parameters now,
Yes, there are four parameters.
and in that OPT you have mentioned one parameter. In that curl easy op,
Yes, 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 yes.
only one parameter. What about the rest of the parameters?
Rest of the parameters are passed by curl directly.
Okay.
Actually, if you want to get a tutorial for libcurl website itself has many sample programs to download to memory, download to file, how to make get request, post request, how to upload file using curl, download file using curl, or how to specify certain customized headers, how to deal with cookies. Everything is specified on the documentation. It is not limited to very simple requests like this. The only thing is that we do not need most of the complex functionalities right now for our POC code. Otherwise, curl library is basically feature complete HTTP and HTTPS library. So suppose if I want my own server and I want my stager to authenticate to C2 server before able to download the modules, or I want my stager to get customized list of modules, that all things can be done. If I want to authenticate, I can authenticate using curl. If I want to maintain a session, I can pass session details using curl, and so on. Any more questions? Okay, it seems that there are no questions. Animesh? Animesh?
अरे मेरा माइक म्यूट था.
अच्छा.
चलो, सबके क्वेश्चंस खत्म.
हाँ, लग यही रहा है. आज का टॉपिक थोड़ा सा डिफिकल्ट है. एंड बाय द वे, इज एनीवन डूइंग द प्रैक्टिस एक्सरसाइजेस दैट आई सजेस्ट इन माय सेशंस?
प्रैक्टिस वाले सारे निकल गए आज लगते इधर से.
हाँ, वो मुझे भी लग रहा है.
चलो. Okay, thank you guys for joining us today. Just be with me a little bit. Just have to send one form. So how was the session? Amazing. Awesome. So we're trying to push one sessions per day because of the lockdown, and because lockdown extended, so yeah, we're coming up with more sessions now. So there's a form. This is a feedback form, that bit.ly/rst. Just fill it up, so that will keep us in shape. And to visit and learn more about our events or upcoming programs and stuff like that, you can visit our website, that is here. And if you have any feedbacks or you want to present a topic to everyone, you can just write an email to me and I'll take care of that thing. So suggestions or feedback that you don't think sending it a form is not a good idea, you can write me directly on hello@aristi.com. Okay. So if you think like we have to include, like you want us to include some new topics, like we're getting a request for web applications or red teaming. So I'm working with those speakers to set up a timing so we can have those sessions as well. If you think you can take care of any other sessions, feel free to connect me and I'll take care of those things. So that will be it. Thank you guys for joining in for today. And we'll see you guys on next session we have is on, let me check.
Animesh, मैं बस सिर्फ 1 मिनट लूंगा इधर.
Uh-huh.
Guys, all the codes that I am sharing with you is actually tested on Arch Linux with latest build of whatever libraries I am using, and latest build of compiler. It may be possible that these make files that I share with you, they may not work on your particular distribution. For example, if you are using Ubuntu, Fedora, Debian, CentOS, or something else, because different distributions package the same libraries differently. and many times you will have different version of compiler than mine. So in case you get compiler errors, let me know. Animesh, please share the email ID with everyone. So if you are getting some problem in running the code on your own particular distribution, let me know the problem. Tell me the compiler version, distribution, and its version, and I will figure out some way to compile it on your own machine.
Search array. So I'm sending you the email address for Mr. Ji. So this will be rerouting him directly to Mr. Ji. So you can send emails to demigod@rst.live. And
बाय द वे ये ईमेल आईडी का आइडिया अनिमेश का था, कोई मेरे पास मत आना कि मैंने ये ईमेल आईडी क्यों चूज किया है.
हाँ, मेरे सबकी email ID ऐसे ही है. वेट फॉर ध्वनि आज ज्वाइन ही करी ना.
नहीं, ध्वनि आज शायद बिजी है.
अच्छा चलो, मैं उसको बाद में देखता हूँ. Okay, so I'll just share my screen, so just I can take you over to, you know, what we are dealing with now. So let me share my screen quickly. Now, so this is our website where you can go through and look for the information. So we have 2 upcoming talks coming up. So these 2 are finished right now. It will be updating very soon. And you can just click on this Google Calendar. It will open up a new window where you can see all upcoming events. So today's 12, tomorrow we have sessions on expert development. You can join in here. We have another on 15th. And new Fun with Malware sessions will be updated within any days. If you think you are able to take any talks, look for the calendar, look for any free slot, update me, and I'll put it there. So for being a speaker with us, you just require 3 things. Better internet connections, mic, and your topic that you're comfortable to delivering everyone. So that's pretty much it. Okay. So I already know Tej is taking care of DFIR. Because of we don't have a proper systems, we are postponing the sessions for a few days. If you guys think that you can deliver on anything related to applications, related to threat teaming, related to system hacking, just come with any topics and we'll assign you sessions. It's just for basically a community service where we're teaching our freshers how things are working on a real-time situations or scenarios. So, yep. Feel free to share your knowledge as well with us. So that will be all for today, and we'll see you guys tomorrow. Have a nice time. Stay safe, and don't go out. We are here to cover you up. So let's wrap up for today. Let's try it.
Yeah, sure.
Okay then. See you guys later. Okay. Thank you, everyone.
Thank you.
Thanks.